Hello, this is Tyler Beamer from Haywood Community College. This is a instructional video for Math 152 and 1, Statistical Methods 1 here at Haywood Community College. The purpose of this video is to instruct students how to use the calculator as an aid in finding binomial probability using the binomial probability formula. I'm going to use our course notes from Chapter 5, Section 3 as a context for the video. As you can see here, this is our course notes. This is the binomial probability formula. This is your formula straight from the book. If you notice, the first part of the formula is your combination formula that you were studying when you did counting rules and finding probabilities, and that was Chapter 4, Section 6. So it's really nice and convenient that you can substitute combination function in for this part of the formula. That's what I'd recommend you doing. It makes the computation a little bit quicker and more efficient. So I'm going to go based off of this formula here, which looks simpler than what we have above. C is your combinations. So the number of ways that we can arrange them where order doesn't matter. And we've got N, the number of trials. X is the number of successes among N trials. We have P, probability of success in any one trial. That's our P here. X is the exponent. That's still the number of successes. Q is the probability of failure in any one trial. So if you know P, you can subtract P from 1 to find the probability of failure. And then that exponent is going to be the number of failed attempts in N trials, which will be N minus X. So that's the formula that you want to use. You could also use the formula above, but like I said, I think this is a little bit simpler. Alright, so I'm going to go down here to this particular example and use that as the context for our problem. So based on the American Chemical Society, there is a 0.9 probability that in the United States a randomly selected dollar bill is tainted with traces of cocaine. Assume that $8 bills are randomly selected. So this is a binomial probability distribution. We've got success, failure. We also have fixed number of trials. So in this case, we can align some of these variables up in our problem. N is 8 because we've got 8 trials, $8 bills, randomly selected. Probability of success is 0.90. And we're going to assume in this case that success is a cocaine-laced dollar bill, since that's what we are studying based off of the American Chemical Society. Q would be 1 minus 0.90, which is 0.10, and that would be the probability of failure. So the probability that you select dollar bill and it is not laced with cocaine. So find the probability that all of them have traces of cocaine. So that would be 8 trials and 8 successes, since all of them would have cocaine. So that would be 8, combination 8 times 0.9 to the 8th power, since we have $8 bills with cocaine, so 8 successes, times 0.1 to the 0 power, meaning we have no failures. One thing that you would want to look out for in your formula, these probabilities 0.9 and 0.1, or whatever these numbers are for your problems, those should add up to 1. And then the exponents should add up to be N, so the number of trials. So that's just something to look out for to make sure you've got your variables set up correctly. So if you want to use the calculator as an aid here, we could do 8, and then to use the combination function we hit math, probability, combination, choose 8. Okay. Figure out what that is. Okay. Times that by 0.9 to the 8th power times 0.1 to the 0 power, and we get our answer 0.4304. So that would be 43% probability. And of course you can use that same calculator function to help you out with the following parts. Find the probability that exactly 7 have traces of cocaine. So 8 combination 7 times 0.9 to the 7 power, since we have 7 successes, times 0.1 to the 1 power, 1 failure, right? 7 plus 1 is equal to the 8, which is the number of trials. So once again, we can use our calculator as an aid. 8 math probability, choose 7 times 0.9 to the 7th power times 0.1 to the 1st power, and we get 0.3826. Okay. We'll just continue the problem. C says find the probability that the number of dollar bills with traces of cocaine is 7 or more. So that would be $7 bills with cocaine or $8 bills with cocaine. So we would want to find the probability of 8 and 7 and add those up. Conveniently, we've already done that in A and B. So we add those up to get 0.8131. And then finally, find the probability that at least $1 bill is found out of 8 that has traces of cocaine. So there's two schools of thought here. You know, at least $1 bill out of the 8 would be probability of 1 plus the probability of 2 plus the probability of 3, so on and so forth until you get to the probability of 8, which would take a while. The easier way to do that is to do 1, which would be the probability that you find no dollar bills with cocaine, plus probability that you find $1 with cocaine, plus 2, so on and so forth, all the way to 8. That would be all of the options, which would equal 1. And subtract out the probability that you find no dollars with cocaine, and that essentially gives you 1 or more, which would be at least 1. So if we find the probability using our binomial function that we have $0 bills laced with cocaine, that would be 8 choose 0 times I'm just going to put this in a calculator so you can get another example of how to use the calculator, times 0.90 to the 0, so 0 successes times 0.18 to the 8th, 8 failures, which is a really, really small number. That's scientific notation, basically saying I need to move this decimal to the left 8 times, so I got 7 zeros in front of that 1. But we're going to do 1 minus this number, so 7 zeros, 1, 2, 3, 4, 5, 6, 7, and a 1. And we get 0.9999. So very high likelihood that we would get a cocaine or laced dollar bill. So very interesting problem. I hope that this video kind of helps you understand how to use your calculator in conjunction with the binomial formula to compute these types of problems. So, all right. As always, let me know if you have any other questions, and enjoy the day.